Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here is a problem for today for exam LTAM. For whole life annuities due of 15 per month on each of 200 lives age 62 with independent future lifetimes, you are given that the interest rate is 6%. A62 upper 12 is 0.4076 and 2A62 upper 12 is 0.2106. Pi is the single premium to be paid by each of the 200 lives. S is the present value random variable at time 0 of total payments made to the 200 lives. Using the normal approximation, calculate pi such that probability that 200 pi is more than S is 0.90. And here's the solution. Let x1 through x220 be the random present values of life annuities due considered. These are independent, identically distributed random variables, and the sum of them, denoted by S, so I added the word let. We let S to be the sum of these 200 random variables. This implies that S is approximately normal, and the expected value of S is the sum of their expected values, which is equal to 200 times E of x1. And then the variance of S, because they're independent, is the sum of variances, so it's 200 times the variance of x1. Now recall that we can write d upper 12 as 12 times 1 minus 1 plus I to the negative 1 over 12. And we have E of x1 equal to 15 times 12 times A double dot 62 upper 12, which is 15 times 12 times 1 minus A62 upper 12 over D upper 12. And now we plug in all the values that we know. And this is approximately 1834.7545. And then the variance of x1 is 15 times 12 squared times 2a62 upper 12 minus a62 upper 12 squared divided by d upper 12 squared. And then we plug in all these values that we know and do the calculation. And it's approximately 426 1,176.9086. Based on this, E of S is 200 times E of x1 we just calculated. That's approximately 366,936.12, and the variance of S is 200 times the variance of x1 we just calculated, so it's approximately 85,235,381.71. And we want 0.90 to be the probability that 200 pi is more than S, which is the probability that 200 pi minus E of S over the square root of the variance of S is greater than S minus E of S over the square root of variance of S, since S minus E of S over the square root of variance of S is approximately standard normal. 200 pi minus E of S over the square root of the variance of S must be the 90th percentile of the standard normal distribution, which is 1.282. This gives the equation 1.282 is equal to 200 pi minus E of S divided by the square root of the variance of S, which is 200 pi minus 366,936.12 divided by the square root of 85,235,381.71, resulting in pi being equal to 366,936.12 plus 1.282 times the square root of 85,235,381.71, the whole thing divided by 200. This we calculate to be approximately 1,893.8597, which is answer E. Please remember this is copyrighted material. The problem itself belongs to Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.